We're going to review graphing patterns with tables. So when you look at your input and output tables and put them on a graph. So let's first look. I'm gonna explain it to you, and you actually have this in the Google Classroom. You're gonna finish putting the things where they go and turn it in, and then I'll look at it. So when it says additive, if I'm looking at an additive pattern, so if you go back to this input-output table, I'm trying to find the rule. How do I get from 8 to 16? I could add 8. So if I go from 10 to 18, the rule is add 8 because 10 plus 8 is 18. If I go from 12 to 20, the rule is add 18. 14 to 22, add 18. So that is called an additive pattern. So here we have the rule 6 plus x. So since we're adding, that is an additive pattern. Here we have 6, and then when it's right next to the x like that, if you remember, a 6 and then right next to the letter, that actually means to multiply. So this really means 6 times whatever that number is, because that is replacing a number. So that number x could equal 2, and you'd be doing 6 times 2, which would be 12. So whatever the x is. So when a number is next to the x, that means you're multiplying. So it's a pattern where you're multiplying. So let's see what this one is. Again, we have x, and it's next to the letter A. It's supposed to be times. Since they're next to each other, that means you're multiplying. So if you'll go and finish putting these on your copy, after we go through, you're going to finish putting them on your copy where each box goes. Then on this screen, we're going to find the rule. So let's look at this table right here. The tables are to the side. You'll see them. So my number is getting larger. It's going from 3 to 6, 6 to 9, 9 to 12, 12 to 15. So since my number is getting bigger, I know that I either have to add or multiply. So how would I get from 3 to 6? I could, if I was multiplying, multiply by 2. So 3 times 2 is 6. But my rule has to stay the same. So if I did times 2 right here, that would mean 6 times 2, which is 12, not 9. So it can't be multiplying. So let's try adding. So 3 plus what is 6? 3 plus 3 is 6. So if my rule is plus 3, let's see if that works. That would mean 6 plus 3 is 9, and that does work. 9 plus 3 is 12, that works. 12 plus 3 is 15, and that works. So you're trying to see if it is an additive pattern, or a multiplying pattern. So again, let's look at this one. 3, if it's plus 3, that's 6. 4 plus 3, that would be 7, so that wouldn't work. 3 times 2 is 6. So let's see if times 2 is our pattern. 4 times 2 is 8. So that works. 5 times 2 is 10. So our pattern is times 2. 6 times 2 is 12. So since we're multiplying, it's a multiplicative pattern. So you're going to add all these on which side that they go. Okay, then we actually have the graphs. We're going to add the graphs where they go. So here on this graph, I have the number 1. I have 0, 1. So it's going up my graph 1. And then it goes over 1 and up 2. And then again, I go over 2 and up 3. Let's look at another one. Okay, this one is at 0, 0. And then it goes 1 to 3, and then it goes to 2, 6. So if I was to write those down, it's 0, 0, 1, 3, and then 2 to 6 is what I'm writing down. Let's see. I can write that. So this one is, that's 0, 0. This one is over 1, up 3, because a baby crawls over before it walks. So you do the X first and then the Y. So that's 1, 3, and then you go over 2 and up 6. So you have 2, 6. So if I'm trying to find what my pattern is, so if I'm looking right here, 1 and 3, let's look at this. How do I get from 1 to 3? I could do plus 2. 1 plus 2 is 3. Let's see if that works for this one. 2 plus 2, well, that's not 6. So could I do 1 times 3 equals 3? 2 times 3 equals 6. So my rule here is just like if I was to make it a table. And my rule goes right here. So my rule is times 3. So since I'm multiplying, 1 times 3 is 3. 2 times 3 is 6. This is a multiplying pattern. So it goes right here. So let's look at this one. What would this one be? I have 0, 1, because you go over and then up. So 0, 1. And then I have 1, and then up 2. And then I have over 2 and up 3. So that would be 2, 3. So if I wanted to find my oh, where'd it go? I lost it. Let me try that again. Let me write that again. 0, 1, 1, 2, and 2, 3. Okay, so if I want to find my pattern, remember it's like a table, so I can draw my line. And so what is the rule? How do I get from 0 to 1? Well, I could add 1. Let's see if that works on the next one. From 1 to 2, you could add 1, and from 2 to 3, you add 1. So that is why this one would be an adding pattern. Okay, let's try one more of these. So let's write out the points. My first one is 0, 0. The next one is over first, 3, and then up 9. So 3, 9. And the next one is 6 and up to 18. So 6, 18. Okay, so now I want to know, let's make it a table. If it starts at 0, 0, we're not going to really look at that one. So let's just start at our actual numbers. So how do I get from 3 to 9? Well, I could either add 6 or 3 times 3 is 9. So I could either add 6 or I could multiply by 3. So let's look at my next one. 6 plus 6, well, that's 12, not 18, so that can't be it. 6 times 3 is 18. So my rule is multiplying by 3. So that makes this a multiplicative or a multiplying pattern. So write them out and see if you can figure out your tables there. Okay, so then you're going to graph. So let's do this graph together and then you can practice some. So it's your turn to graph. You're going to complete the table below for the rule. So here's our rule. Y equals 4 plus x. So our rule is, here's our x. X equals 2, 4, and 6. And my rule is I'm adding 4, so it's an additive pattern. So if I add 4, add 4, so 2 plus 4 is 6, 4 plus 4 is 8, 6 plus 4 is 10. So that makes this an additive pattern. And then we're going to plot our points. So I'm going to go and plot them with this first because it'll erase. So I'm going to go to have the x is 2 and the y is 6. So I'm going to go over 2, up 6 because a baby crawls before it walks. Over 4 and up 8. I'm sorry, so this was additive. Over 4, up 8. Over 6, up 10. Over 6, up 10. Okay, so then you can actually drag your points. Oh, they left me because I erased it. So I think it was I don't remember what it was. So when you drag your points, you can write on yours and it won't go away. Mine goes away right now. And then you're going to add your points to where they actually go, wherever they go on there. So here's another one. Again, there's your rule. So anytime I have a number next to the letter, that means I'm going to multiply. So 3 times the x. So here's my x's, and my rule is actually going to be times, and it wants to do 3 times the x. So my rule that goes right here is times 3. 4 times 3, 6 times 3. So then I would do 2 times 3 is 6. So then I know my first one. This is now a multiplicative pattern because I'm multiplying. And I have the x is 2 and my y is 6. So over 2 and up 6 would be my first one. So then you can do this, and then you're going to plot your points where they go. So you have another one you're going to do that on. This one is a decimal. So same thing, we worked on multiplying decimals when you were over with me at Noble Read. So it's the same thing. This one we're adding, because there's an add sign. So you're going to be adding 2 and 5/10. So my rule is plus 2 and 5/10. When I'm adding decimals, we line up our decimal. And so 0 plus 2 and 5/10 would actually still be, if I'm adding 2 and 5/10, that would still be 2 and 5/10. I'm adding 3 plus 2 and 5/10. 2, not 3. Then make sure on the side we come over here and we say, let's do it where we can see it. We say 3, put your decimal after, because all whole numbers have zeros after. Fill in your zeros, put your 2. And then you can add straight down. Use your graph paper to help you like we showed you. And you have 5 and 5/10. So do the same thing for this one. Now if I wanted to plot this, I would plot 0 and 2/5. So I go to my x. I have nothing to go over because it's 0, and I would go 2 and 5/10. So here's my whole number 2, 2, 2. 5/10 is the same thing. If I had a 0 after, it would be half, because 50 cents is half of $1. So if this is 2, I know this is 3. So between 2 and 3, halfway would be 2 1/2, or 2 5/10, or 2 50 hundredths. The same thing here, 5 and 5/10. I would go, well, first I need to go to my 3 because my x is 3. So over 3. My whole number is 5, so I'm going to go up 5. 4, 5, 6, up 5. And then I'm at 5/10, which we said if we added a 0, that's the same as 50 cents, which is half a dollar. So it's really halfway. So here's 5, and I'm going to go halfway, so my dot would actually be here. So go through and so add your 2 and 5/10 here, find your y, and plot your next point. And since we're adding, again, we know that is an additive pattern. Okay, here we're problem solving. We're going to write an equation that represents the pattern seen in the graph. Let's see. So we want to find, we're going to write the points. So this first point, it's over 1, it's up 6. So this point would be, I'm going to write them going down so I can make a table. 1, 6. This next one would be over 2, up 7. So you have 2, 7. Same thing here, 3, up 8. So you have 3, 8. 4, up 9. So you're going to do 4, 9. And the last one is 5, 10. Okay, so we want to write an equation. So first I need to figure out what my equation is. So I am going to make it a table. And find my pattern. 1 to 6. Well, it's getting bigger, so I can either add or multiply. So I'm adding 5, or it could be 1 to 6. I could times 6. Okay, so let's look at the next one. 2 to 7. 2 plus 5 is 7. 2 times 6 is not 7. So I know it must, let's check, make sure it has to be plus 5. 3 plus 5 is 8. 4 plus 5 is 9. 5 plus 5 is 10. So our equation would be, I'm missing y, so it would be y equals x, because that's what I have. I have my x plus 5, because this is my x, this is my y, so I have x plus 5 equals y. So y equals x plus 5. So is this pattern additive or multiplicative? How do you know? It would be additive because we added 5. And then it said to extend the pattern, what would we do? Well, if I know my pattern is to add 5, then I'm going to add 5 to each one because my pattern would go right here. And I could extend my table. So that would give me 9 plus 5 is 14. 10 plus 5 is 15. 11 plus 5 is 16. So that is how you'd answer one of those the same way. So you're going to try this one. And this one actually gives you a table instead. So you're actually finding the rule just like it would be a table. So a table and a graph are the same thing. Here's your y, here's your x, here's your y. 1 6, 2 12ths, 3 18ths, 4 24. So if I was to plot this on my grid, I would grid 1 over 1 up 6. There's my 2 over 2 up 12. My 3's on the x, so over 3. My y is 18, so up 18. My 4 would be over 4 up 24. So when you have a table and a coordinate grid, it's just showing you what the grids are. Okay, let's try one problem solving together. Jennifer used the rule y equals x plus 4 to complete a table of values and to make a graph to represent the table. Which coordinate pair will be represented on Jennifer's graph? So I have the coordinate grids. I have 3, 7, which would look like 3, 7 if I was graphing it, over 3 up 7, 5, 9, 7, 11, 9, 13. So my numbers are getting larger, so I know that I either need to add or multiply. I'm going to start with adding. Oh, it tells me right here actually. Sorry. My rule is to add 4. So I'm going to, here's my x, 3. And I'm going to add 4 to it. So 3 plus 4 is 7. So my rule is plus 4 all the way down. So which pair would be represented? Well, if my rule right here is plus 4, 4 plus 4 is not 22, so that would not work. 16 plus 4 is not 32. 8 plus 4, well, that's 12, so that would work. 2 plus 4 is not 4. So my answer has to be C, because 8 plus 4 equals 12. And so that's how my problem would be correct. So then the next slide will give you a different problem. And remember, if a number is next to the x, what does that mean? Means to multiply. Also means to multiply if I have 3 and then it's next to the parentheses. If it looks like this ever, that also means to multiply. So if it's next to it, it means to multiply, and if it's next to the parentheses, remember that means to multiply. Okay, there's you another question with words. Don't let it, just because it has words, throw you off. After you're done, you're going to share it with me back. So you're going to put all the pieces where they go, and it will turn it in when you save it into the Google Drive, and then you have other things to work on after this page.